The lecture today about the reactions of anhydride. Okay, he said the less reactive one can be prepared from the more reactive one. Okay, the less reactive one can prepare from the acidic chloride, because the acidic chloride, it is the more active carboxylic acid derivative. Anhydride readily react with most nucleophile to form substitution product. Okay, that meaning we have here acyl group. The acyl group can be replaced with the nucleophile. Okay, with the most nucleophile, with the stronger nucleophile. Most يعني stronger nucleophile to form the substitution product. Nucleophilic substitution reaction of anhydride are not different than the reaction of other carboxylic acid. The same mechanism. We have a new nucleophile. The nucleophile, it will be attacked from to this carbonyl group, and then the leaving group, it will be go out from the structure to give you the substitution product. Okay, to give you the substitution product. That meaning this nucleophilic attack occur at one carbonyl group. We have here for the anhydride, we have two carbonyl group. We have this and this. Okay, that meaning the nucleophile, it will be attacked on this carbonyl or this carbonyl, either this or this. Okay, one of them. If the nucleophile attack this carbonyl, that meaning this, it will be the leaving group. If this nucleophile attack this carbonyl, that meaning this part, it will be the leaving group. Okay. Now here the nucleophile, it will be attack this part, and this, it will be leaving group to give you the product. Okay, the product and the side product. Now we take reaction. Look, this for general reaction. This nucleophile H2O, this anhydride, this hydrolysis for the anhydride. Okay, this reaction is the hydrolysis of the anhydride. That meaning H2O will be react without and this carbonyl, and this, it will be go out as a side product as carboxylic acid, and here will be have two product of the carboxylic acid. We have two carboxylic acid. Okay, that meaning if the anhydride react with the H2O, it will be give you two carboxylic acid compound. If the anhydride react with the alcohol, that meaning one of them, it will be ester, and the other, it will be carboxylic acid side product. If the anhydride react with ammonia, NH3, it will be give you primary amide, and then the side product, if the acetate product, ammonium acetate product. Then replacing NH3 with primary or secondary amine, okay, to this two equivalent, primary to form secondary or tertiary amide, respectively. Okay, that meaning if you use primary amine, it will be give you secondary amide. If you use secondary amine, it will be give you tertiary amide, like this. طبعا this homework, he said draw the products forming the benzoic anhydride, this benzoic anhydride. Okay, benzoic anhydride meaning this here we have phenyl group, also we have phenyl group. This compound called benzoic anhydride is treated with each nucleophile. We have H2O like this, we have H2O, we have alcohol, we have ammonia. Okay, that meaning just replace the R group with the benzene ring, with the phenyl group. Replace the R group with the phenyl group, and it will be give you the same product. Okay, this homework is easy also. Next is the mechanism. It's the same mechanism. We have the addition of the nucleophile, and then the leaving group. Because our nucleophile here is equal charged, okay, without negative charge, that meaning we need additional step to remove the positive charge from the next step. Okay, now the NH3 nucleophile attack this carbonyl, okay, attack, and this pi bond, it will be open on the oxygen to give you negative charge, and here we have NH3 plus. Okay, now we have a plus, we have minus on the oxygen. Okay, Minus on the oxygen, no problem. It will be removed because it will be make pi bond, and this part it will be leaving room. But how we can remove this positive charge? We can remove this positive charge by deprotonate. We say deprotonate, يعني remove a proton from the nitrogen. Okay, remove a proton from the nitrogen. We have excess energy 3. Okay, we have excess energy 3, 2 equivalent of the base like this. Look here, 2 equivalent of the base here, energy 3. Okay, also here he said CH3 by 2NH excess. That meaning more than 1 mole. Now remove this proton and to give you the NH2 group. And final step, just the negative charge on the oxygen, make pi bond, okay, double bond, and this bond between carbon and the leaving group, it will be broke out to remove the leaving group from the structure to give you the amide, the primary amide. Look, we used ammonia, give you the primary amide. If you use secondary amine, primary amine, sorry, it will give you secondary amide. If you use secondary amine, give you tertiary amide. Okay, this is the meaning here. He said instead nucleophilic attack by the removal proton, from the elimination leaving group. Remove a proton, that meaning deprotonate. We said elimination. Okay, remove the proton. Remove the proton from here. Remove the proton meaning deprotonation. Yani remove a proton. The same thing. If you say deprotonation of the NH3 group, that meaning remove a proton from the NH3 group. Okay. Anhydrides react with alcohol. Okay, we look here, we have anhydride and we have alcohol and amine with easy to reaction of the anhydride with alcohol. Okay, so they are often used to the laboratory to prepare ester and amide. Okay, to prepare the ester and amide. That meaning if you have anhydride react with the alcohol, give you ester, because this, it will be replacement here. It will be carbonyl or R. That meaning it will be ester. Okay. Now, if this your nucleophile, this OH your nucleophile, that meaning it will be give you CH3 carbonyl or benzene this compound. Okay. طبعا this compound is aspirin. Aspirin, you know the aspirin is a drug. Also so important, but also look, it is easy to prepare on the laboratory, okay, by just one reaction between this anhydride and this compound. This is the phenol compound, okay. This we said orthohydroxy benzoic acid. This orthohydroxy benzoic acid, okay, between the orthohydroxy benzoic acid and the acetic anhydride. Okay. Also, the acetic anhydride can be react with the amine to give you the amide. Okay, to give you the amide. Okay, this NH2, it is your nucleophile. Okay, it will be attack this carbonyl to give you this compound. Okay. Now the reaction of carboxylic acid. We finished from the reaction of anhydride. Now he will talk about the reaction of the carboxylic acid. Now, no question. Yes. Do you have any question? Okay. Reaction of carboxylic acid. Carboxylic acid are strong organic acid. Why strong? Because their conjugated base is stable. Okay, that meaning this carboxylic acid will be strong. Okay, we know this because acid-base reaction proceed rapidly, and any nucleophile that is also strong base will react with the carboxylic acid by removing a proton first. That meaning any nucleophile, the first thing it will be remove the proton. Because the carboxylic acid is a strong base, proton donor. Okay. Maybe you will be say the nucleophile can be attack this carbonyl. Okay, this reaction, if the nucleophile attack the carbonyl and give you minus here to give you this intermediate, yes, it is possible, but the first reaction is the faster one. Okay, this is really just if you use base with carboxylic acid, it is readily give you a carboxylate anion as conjugated base, and this conjugated base is more stable than this. Okay, more stable than this. For this reason, this is the first one, is the preferred one, and is fast, easy to occur. Okay, that meaning we have two possible way for the reaction of the carboxylic acid. We have the nucleophile, it will be react with the proton for the OH group, or the nucleophile it will be attack or react with the carbonyl for the carboxylic acid group. Okay, and how we can convert the carboxylic acid to acid chloride. Okay, here directly we said before that the more reactive one, anyone is more reactive, this or this. Actually, this is the more reactive one. Okay, the more reactive one can be converted to the less reactive one. Okay, but the less reactive one, it is not likely or not good to prepare for the to convert to the more reactive one. We know that. Okay, but by using special reagents, special reaction, sometimes the less reactive compound, less reactive carboxylic acid can be converted to the more reactive one, but by using, special reagents, special reaction. Okay. Then he said, carboxylic acid cannot be converted to the acid chloride by using nucleophilic reaction, by using Cl as nucleophile. Okay, we know this because the attaching nucleophile of the Cl minus is weaker base than departing leaving group. He said Cl minus is weaker nucleophile with OH. If you compare the OH minus with Cl minus, anyone is stronger nucleophile. Of course, the OH minus is the stronger nucleophile. Okay, that meaning cannot be removed. That meaning the Cl minus cannot remove the OH from the structure. This is the meaning. Okay, this is the meaning. But carboxylic acid can be converted to the acidic chloride using thionyl chloride, SOCl2. This special reagent, SOCl2. How the mechanism? Yes, we have here the mechanism. بله.
بس قلت لي less reactive can convert.
Less reactive. Where is here?
Can convert to more reactive by
a less reactive one. This carboxylic acid can be converted to the more reactive one by special reactions. Okay, not by nucleophilic attraction. By special reaction, by special reagent. Okay, special reagents. يعني تفاعل خاص. reagent خاص. Okay. Then this finish. Is this your question? Okay. Now conversion. The mechanism. Look for this reagent, for the thionyl chloride. How it will be work? Look, thionyl chloride has partially positive here on the sulfur. Okay, because we have halogen here, chlor and chlor oxygen. All of them, this chlor and oxygen, the chlor is withdrawing groups. Okay, withdrawing groups. That meaning this partially negative, this partially negative, this partially negative. That meaning we have strong partially positive here. Okay, that meaning we have strong allotrophil. The sulfur group here is strong allotrophil. Okay, now if you put thionyl chloride with carboxylic acid, okay, if you put thionyl chloride with carboxylic acid, there is no acid-base reaction here. Okay, there is no acid-base reaction. That meaning there is no proton donor or a proton acceptor, because this cannot be take the proton. Okay, now what will be happen? That will be happened here. The N shape of electron for the OH group, it will be react as nucleophile. It will be attack the sulfur atom. Okay, and the one of the halogen, it will be removed as leaving group. We know the halogen group is good leaving group. We know this. Okay, now this it will be attack, and this it will be leave this structure. Okay, to give you this intermediate. Okay, that meaning we have a new bond here, oxygen sulfur, a new bond. This oxygen sulfur, a new bond. Okay, now we have positive on the oxygen. How we can remove the positive on the oxygen atom? By deprotonation, by remove the proton from the oxygen. Okay, we have Cl minus. Cl minus easy attack the proton. Okay, that means this acid-base reaction attack the proton, and this both of the electrons to be come back again to the oxygen to give you this intermediate, this compound. Okay, this compound plus HCl as the acid. Now, look what it will be happen for the next step. We have Cl minus. Okay, we have from the HCl. We have that meaning we have Cl minus. The Cl minus, it will be attack again this carbonyl. Okay, attack this carbonyl again. Okay, as nucleophile. And this it will be open to make the negative charge. Now, we have this group. This group can be leaving group. Yes, it will be can be leaving group. This group. How? The negative charge make pi bond, and this it will be open to here, and this it will be leave. Look, we have oxygen, sulfur, oxygen, SO2, SO2 gas, and we have leaving group Cl minus, and we have our product. It will be have our product. It will be acid chloride. We have acid chloride. Okay, that meaning we have a special reagent here. Our special reagent is the thionyl chloride. The thionyl chloride, it will be work different from other than nucleophile. It is not nucleophile here. It is electrophile. Okay, that meaning it is a special reagent and a special reaction and other mechanism for the reaction. But look, from the less reactive one, we prepared more reactive one. Okay, in the normal case, impossible to prepare less reactive compound from the more reactive one. But here is easy by using thionyl chloride to give you the acid chloride. Okay, is easy. Draw the product of each reaction. We have this. Okay, carboxylic acid and thionyl chloride. That meaning just we'll remove the OH and put a chlor. How the mechanism? This is the mechanism. Okay, look here. He convert the carboxylic acid first one to the acid chloride, and then with the excess of the secondary amine. This is secondary amine. That meaning final product it will be amide. It will be tertiary amide. Okay. Be careful. We have here two reaction. Reaction 1, reaction 2. That meaning we will have a tertiary amide. طبعا easy. Just remove the OH and put the NCH3CH2 by 2. That meaning 2 alkyl group. On the nitrogen, it will be tertiary amide. It will be tertiary amide. Okay. No question here. No question. Okay. Now, the conversion of carboxylic acid to the anhydride. Look, for the anhydride, carboxylic acid cannot be readily converted to the anhydride. Okay, we say it cannot. That meaning if we have carboxylic acid, cannot be converted to the anhydride. Just one case, just if you use dicarboxylic acid. Okay, but the dicarboxylic acid can be converted to the cyclic anhydride. Look, dicarboxylic acid can be converted to the cyclic anhydride. This cyclic anhydride. Just in this case, if you have double carboxylic acid group on the same compound, okay, can be converted to the cyclic anhydride just by heating to remove the H2O from the structure. Okay, just by heating. This dehydration, طبعا heating remove H2O, meaning dehydration reaction. Dehydration remove the water molecule from the structure. Okay, this dehydration reaction because I said remove the water molecule from the structure. Okay, now take this double carboxylic acid, that meaning remove one H, and this it will be make double bond here. This oxygen, it will be make double bond here, and this OH, it will be removed with this hydrogen minus H2O to give you the cyclic anhydride. The cyclic anhydride. Okay, just in one case. Okay. Now, conversion of the carboxylic acid to the ester. This ester. Okay. طبعا, we take this reaction before that. I say to you, it is the esterification. Okay, that meaning if you have carboxylic acid and you have كحول. Look, كحول is a neutral nucleophile. Okay, a neutral nucleophile, that meaning we need catalyst. Okay, where our catalyst almost it will be the acid or proton acid. Okay, H plus. That meaning this reaction between carboxylic acid and alcohol can be happened by using acid, by using catalyst. Okay, now what will be happened before we said the oxygen here, the oxygen, it will be protonate with the acid, and then to give you the carbocation, and then the alcohol is easy attack this carbocation to give you the product. I think we have the mechanism. We take the mechanism before that. Okay, in the first lecture, I think. You can come back to see the mechanism, easy mechanism. It is the esterification and it is easy reaction. But this reaction, we have side product here. We have the H2O side product. Okay, that meaning if we remove the H2O, the reaction will be faster. Okay, dependent on the Le Chatelet principle. Okay, we'll take the Le Chatelet principle here. The reaction is equilibrium. That meaning we have equilibrium. What meaning equilibrium? That meaning it will be possible to come back again. The ester, maybe it will be come back again to the carboxylic acid and alcohol by hydrolysis with the H2O. Okay, because we have H2O here. H2O, ester, acid, it is the hydrolysis with acid to give you carboxylic acid and alcohol. Okay, now he said we can prevent the bag reaction by removing the water. Okay, I think you take it the Le Chatelet principle before that. If we remove, if we increase the volume, the volume is of the reactant, that meaning the reaction will be pushed on this side from the left to the right. Okay, if we increase the volume of the one component of the product like H2O, if you added H2O, additional H2O, that meaning the reaction will be pushed on this side. Okay, from the right to the left. This is the principle, Le Chatelet principle. Also, by increasing the heating, the pressure, the Le Chatelet principle depended on the many factors: the pressure, the heating, the volume, the volume meaning the concentration. Okay, now then it is, look, you have this, for example, you have CH3 and this carboxylic acid, acetic acid, and we have ethanol. By using H2SO4 as catalyst, it will be nucleophile. This, it will be attack this, and the OH, it will be removed to give you the ethyl acetate. okay, to give you the ethyl acetate. And for example, we have here benzoic acid with methanol acid. That meaning this, it will be nucleophile attack here. That meaning this group, it will be substituted here, and OH, it will be removed from the structure to give you methyl benzoate. Methyl benzoate. Okay, where is the mechanism? This is the mechanism. This is the mechanism for esterification. Look, the first step is the protonation of the of the oxygen atom for the carbonyl group by the acid to give you OH plus. Now, OH plus, طبعا OH plus, we have resonance here. Okay, we have two resonance structure. This is the first one, and the second one, this is the pi bond. It will be open on the oxygen, and we have carbocation here. Okay, that meaning we have resonance here, and this, it will be strong partially positive, and the other one, it will be full positive charge as carbocation. Now, alcohol can be easy to attack this carbon. Alcohol is easy to attack the carbocation, okay, because the carbocation is full positive charge. Okay, now attack the carbocation to give you this intermediate. Now, how we can remove the positive charge from the oxygen? We said by using deprotonation. Okay, deprotonation to give you the this intermediate. We have OH, and we have OR. Now, we have two OH group at the same carbon. Okay, we have two OH group at the same carbon. The next step, because we have also acid, okay, one of the hydroxyl group, it will be attack the proton to give you OH2 plus, and now the OH2 plus is good leaving group. That meaning convert the OH group, the poor leaving group, to the good leaving group. Okay, the unshapophilic electron make pi bond, and this, it will be leave this structure. Final step also the deprotonation to remove the positive charge from the oxygen to give you the final product, the ester compound. Okay, this is the mechanism for the esterification. Okay, look, if you look to the mechanism for the esterification, this acid-base reaction, this acid-base reaction, this acid-base reaction, this acid-base reaction. That meaning you have 4-step acid-base reaction. Okay, and just this step, where is this step? This nucleophilic attraction, this nucleophilic substitution, and also this is leaving group. It will be remove the leaving group. Okay, and the remaining step just acid-base reaction, acid-base reaction, acid-base reaction. Okay, that meaning, in my opinion, is easy reaction, easy mechanism, and it is very useful for the organic synthesis. Okay, this reaction is very useful in the organic synthesis. Now he said the intermolecular esterification. Okay, it can be happened if you have intra OH group with the carboxylic acid at the same compound. We said atramolecular esterification. That meaning the reaction, it will be happened at this on the same structure. Just you have just one starting material. Okay, one starting material. This one is starting material, but this starting material have the both group, have the OH group, have the carboxylic acid. Okay, acid-base reaction. That meaning we have a new bond here. This, it will be make a new bond here. Okay, a new bond here to give you the lactone. Lactone, it is we said cyclic ester compound. Look here, this OH group, this oxygen, it will be make a new bond here with this carbon. That meaning it will be give you this compound, this lactone. Okay, just think you have, if you have all the time, if you have Kuhul with the carboxylic acid and acid, this reaction is the esterification, give you the ester product. Okay, I think this is clear. Now this homework for you: draw the product of reaction. I just want from you to draw the product. I want to draw the product. Draw stepwise mechanism for the following reaction. Look, we have here Kuhul and we have carboxylic acid. That with acid, that meaning this reaction is the esterification. Okay, be careful here. Is the esterification reaction. Okay, draw the mechanism for me, or the mechanism. Now conversion of the carboxylic acid to the amide. Now, the direct conversion of the carboxylic acid to an amide with energy 3 or an amine is very difficult. Okay, why? Because the conversion the carboxylic acid to an amide with energy 3 of an amine is very difficult. Okay, that meaning cannot be. Why? Because it will be happen acid-base reaction. Because the energy 3 is strong base, and carboxylic acid is strong acid. That meaning the acid-base reaction it will be happened. Okay, that meaning the ammonia energy 3 here, it will be react with the proton, not react here with the carbonyl. Okay, he said it is difficult, very difficult. Why? Why very difficult? If in your exam I said to you the carboxylic acid cannot be converted to the amide directly, but with the reaction with the energy 3, you say to me because the acid-base reaction it will be happen, not the nucleophilic substitution reaction. We will have acid-base reaction. Okay. Now to give you ammonium salt of the carboxylic acid. Now just we have additional step, heating. Okay, we have heating for the dehydration. Remove the H2O from the ammonium salt to give you the amide. That meaning we need additional step. We need heating step. Okay. طبعا he said we said why it is difficult, because this reaction between carboxylic acid and the energy 3 will be undergone with the acid-base reaction to form ammonium salt, and the ammonium salt before it will be formed before any substitution reaction. We don't have substitution reaction here, just acid-base reaction. Now we have additional step. We remove the H2O from the ammonium salt by using heating to give you the amide. Okay, to give you the amide. Now look to this. Therefore, the overall conversion of the carboxylic acid to the amide, any amide, this is the primary amide, requires 2 steps. Okay, requires 2 steps. Acid-base reaction of the carboxylic acid with energy 3. Look, the first one, acid-base reaction of the carboxylic acid with energy 3 to form ammonium salt. The second step, dehydration by heating. طبعا by more than 100. Why by more than 100? Because we know the H2O molecular, the boiling point for the water is 100. Then the H2O molecule can be removed from the structure by heating more than 100, not less than 100. Okay, now carboxylic acid and an amine readily react to form amide. Okay, now if you have, look, if you have amine like this amine, not ammonia, not NH3, amine. Okay, amine, it will be convert to the amide in the presence of additional reagent. That meaning we need additional reagent also. Okay, what is our reagent here? Our reagent here, this dicyclohexyl. We have dicyclohexyl, دو حلقة. Dicyclohexyl, carbo, this is the carbo diamide. Okay, we مختصر DCC. Okay, DCC, dicyclohexyl carbodiamide. This is the reagent which is converted to the byproduct. It will be converted to the byproduct is the dicyclohexyl urea. This dicyclohexyl, this urea. Okay, this urea. You know the structure of urea, NH2, carboline NH2. This is the urea. Okay. Okay, now we have carboxylic acid and we have a primary amine. It will be give you secondary amide. Okay, it will be give you a secondary amide. Now, what is the work of DCC? The work of DCC is the dehydrating agent. Okay, dehydrating agent. Look here, we have N carbon N, but here we have N hydrogen, carbon oxygen, N hydrogen. That meaning we have H2O molecule. If you react this compound with the H2O molecule, give you this compound. That meaning this reagent is removing H2O from the structure, removing the H2O from the structure. We say dehydrating agent. Dehydrating agent meaning component can be removed or can be take water molecule from the second component. Okay. Now the DCC, this is the byproduct formed by adding the elements of the H2O to the DCC. The DCC bromide amide forming by converted the carboxylic acid OH group to the beta leaving group. Okay, to the beta leaving group. Now you have, look, you have this carboxylic acid and you have here primary amine. DCC, of course, it will be give you secondary amide. This is the secondary amide. Nitrogen, carbon is secondary amide. Okay. What product is formed when acetic acid is treated with each agent? Look, with the primary amine and B, this also with primary amine and then heating. Okay, this with the primary amine and DCC. Okay, I want from you to draw the products. Okay, to draw the products. Now, reaction of ester. The ester compound can be converted into carboxylic acid and amide. Then, look here, this ester compound, H2O, acidification or by using base. If we said acidification, it is reverse to the acidification reaction. We take the acidification reaction before that. We have carboxylic acid with H2O, with alcohol, this alcohol, carboxylic acid, and acidification give you ester. هذا عكس ester, عكس التفاعل ester. Reverse to the acidification reaction, okay? That meaning we have ester component, hydrolysis with the acid or base. If you use acid, give you carboxylic acid and alcohol. If you use base, give you carboxylate anion and alcohol. If you, for example, use NaOH, it will be give you here Na. If you use KOH, it will be give you K. Okay? Potassium carboxylate anion. Now, ester react with ammonia, this ammonia and amine to form primary, secondary, and tertiary amide. Okay? This, if you use ammonia, give you primary amide. If you use secondary amine, give you if you use primary amine, give you secondary amide. If you use secondary amine, give you tertiary amide. Okay, and tertiary amine cannot be react with the ester. It will be give you salt. Now, ester hydrolysis in aqueous acid. Ester hydrolysis in aqueous acid. Now you have here ester, H2O, acid. The hydrolysis of the ester in aqueous acid, it will be give you carboxylic acid and alcohol. أو طلب عكس تفاعل acidification. Reverse to the acidification reaction. عكس بالضبط. Here, from the right to the left, acidification reaction. From the left to the right, it is the hydrolysis of the ester. Okay, how the mechanism it will be happen? Look, we have acid for the same thing. The anship of electron attack the proton to give you OH minus, OH plus. Now the OH plus, we have resonance structure here and we have carbocation. H2O is easy. It will be easy to attack the carbocation to give you this intermediate. Now we have the nucleophile we have the negative part of the acid. This from the acid we have negative part. It will be take the proton to give you OH, OH, and ester. And the final step here, the unshape of electron here, it will be attack the proton acid-base reaction to give you this group. Now this group is good leaving group. Unshape of electron make the pi bond, and this it will be leave the structure to give you this intermediate. Now with positive charge on the oxygen, the just deprotonating to remove the positive charge to give you the carboxylic acid compound. Okay, this is the mechanism. يعني عكس mechanism الesterification بالضبط. عكس mechanism esterification. The reverse to the esterification mechanism. Okay, this is the hydrolysis of the ester by using acid. Ester hydrolysis in aqueous base. Look here in aqueous base. This, if you have aqueous base, that meaning it will be give you carboxylic acid anion, carboxylate anion. We said carboxylate anion, and the methanol. The mechanism. This is the mechanism. This is strong nucleophile. Okay, directly it will be attack this carbonyl, and then the negative charge make another pi bond, and this it will be leave the structure, and then if this leave the structure, it will be OR minus, OR minus, OR minus is strong nucleophile or strong base. It will be take a proton from the OH to give you carboxylate anion, and كحول. Now the mechanism of the ester hydrolysis by using base is easy than the mechanism of the esterification hydrolysis in acidic medium. Okay, why? You know, because here already we have strong nucleophile here. Already we have strong nucleophile, the OH minus. Then he said, yes, this like next the carboxylic acid. The carboxylic acid is strong acid, yes, strong organic acid, and the leaving group are strong base, yeah. So acid-base reaction will be occur on the final step. He said here, he said because this is strong base and this is strong acid, that meaning the reaction will be happened between of them to give you carboxylate anion, to give you the carboxylate anion as the final form, okay, the final product. This. The carboxylate anion is resonance stabilized. Yeah, we know it is resonance stabilized. So acid-base reaction occur. Yeah, we know it is can be this is resonance stabilized, and the acid-base reaction can be happened if you have strong acid. Okay, if you have strong acid. Yani just if you have this just added acid. Strong acid like H2SO4, HCl, directly it will be give you the carboxylic acid. Directly it will be give you the carboxylic acid. Okay. Finally here the reaction of amide. We know the amide is the less reactive carboxylic acid derivative. The amide, okay, is the less reactive one. Now, any reaction can be undergo for the amide component because the amide have the poorest leaving group. Look, it is the less reactive compound. All the carboxylic acid derivative, they are less reactive. Yes, we know that. And under the reaction condition, amide are hydrolysis. The hydrolysis of amide. In acid or base, the amide undergo hydrolysis by using acid or base to give you, if you use acid to give you carboxylic acid, if you base to give you carboxylate anion, and the ammonia as side product. Look, it is like ester. Ester can be hydrolysis to give you carboxylic acid or carboxylate and كحول side product. Here no, your side product. Just 1 minute, give me 1 minute, طلبة. Okay. Sorry about that. Okay, that meaning it is the same for the ester compound. The amide can be hydrolysis to give you Also, carboxylic acid, if you use acid, or if you use base, hydrolysis with base give you carboxylate anion. But the side product is it will be amine, not kahol. The ester give you kahol. Here the amide give you amine. Okay, the same thing. طبعا in acid, the amine byproduct is a protonate as ammonium. Yes, if you use the acid, the amine it will be protonate as ammonium ion, whereas in the base, a neutral amine, it will be formed. Okay, it will be formed. That meaning if you has here acid, your amine it will be protonate to give you this salt. But if you use base, no, the carboxylic acid it will be deprotonate by the base. It will be give you carboxylic acid, carboxylate anion. This carboxylate anion and you have amine. This carboxylic acid, but you have here ammonium ion. Ammonium ion. This the effect of the acid and base way. Okay, this is the difference here. Okay, now this amide hydrolysis with the acid, this H3O plus meaning hydrolysis in acid. Okay, give you carboxylate, carboxylic acid and the ammonium salt. This here hydrolysis in base. Look, be careful. Your product it will be carboxylate anion. Why? Because the base and the amine, the methyl amine. Okay, طبعا the same mechanism also. If you use the base hydrolysis in base, I don't give you the hydrolysis in acid. Just take this. The hydrolysis in base is easy for you. The OH minus it will be attack carbonyl and pi bond it will be open on the oxygen to give you a negative charge. Now the negative charge it will be make double bond and NH2 it will be removed from the structure. Finally, we have here acid-base reaction between NH2 minus and the OH group to take a proton, and it will be give you carboxylate anion and the NH3. Okay, is easy mechanism. I think it is easy mechanism. If you have a question, you can ask. Look here, homework, draw the stepwise mechanism for the following reaction. Look, we have amide. What this? It is amide. Okay, amide, cyclic amide. That meaning we have hydrolysis in the OH. In the base, we have hydrolysis in the basic medium. That meaning we have open cyclic here. This is the cyclic amide. The lactam, we said lactam, it will be open from here. It will be open from here, from this side. This it will be open to give you this compound. Okay, I want from you to draw the mechanism. This is important mechanism, and also easy mechanism like this, like this. Okay. Summary of the nucleophilic acid substitution reaction. This just for memorizing to help you for your study, organize and remember all the nucleophilic acid substitution reaction that can be occur at the carbonyl carbon. Keep in mind the following two principles. The better leaving group, the more reactive of the carboxylic acid derivative. Okay, we know this. More reactive acyl compound can always be converted to the less reactive one. Okay, the reverse is not usually true. Okay, the reverse need special reagents like SOCl2. Okay, special reaction. Now, the result in the following order reactivity. That meaning this is the more reactive one, this is the less reactive one. Okay, the more reactive one can be converted to the less reactive one, but the less reactive one cannot be converted to the more reactive one just by using a special reagent. Now here, look, if you have a starting material like acid chloride, okay, can be converted to the acid anhydride, can be converted to the carboxylic acid, can be converted to the ester, can be converted to the amide. If your starting material anhydride, cannot be converted to the acetic chloride, but can be converted to the acetic acid, ester, amide. If your starting material carboxylic acid can be converted to the acidic chloride, can be converted to the anhydride, can be converted to the ester, can be converted to the amide. Okay, look, that meaning carboxylic acid is also important. Okay, because can be converted to the all the other derivative. If you have ester, this the ester compound. The ester compound cannot be converted to the acidic chloride or anhydride. Just it will be converted to the carboxylic acid and the amide. Okay. If your starting material amide, just you can convert the amide to the carboxylic acid derivative, but you cannot convert the amide to the acidic chloride or to the acid anhydride or to the ester compound. Just you can prepare the carboxylic acid derivative from the amide. This table is useful for you to remember the reaction of the carboxylic acid derivative, or any derivative can be converted to the second one like this. Okay, this is very useful for you. Okay, and take in this important notes and this important notes and also this important notes. Be careful again. Listen again to my lecture, and please use paper and pen to resolve all the homework. Also, when you study organic chemistry, you have to take a paper and pen and write the structure. It will be easy for understanding. And if you have any question, I am ready. If you don't have a question, you can take your time, and see you inshallah for the next lecture.